Hello again, and welcome back to FSD TV. I'm your host, Mark Sonny. And have you kids ever wondered how you know particles are floating all around us? Well, today, Brendan Ledden is going to show us how they can prove that they're there. So, Brendan, take it away.
Hi, thank you for having me back. My name is Mr. Ledden. I'm here for the second part of our gravity lesson, and that particles are too small to see. So we have just a quick review from last time I was here. We had some unanswered questions. We had the question of what made the paper fall slower, what made it move back and forth as it fell, and so we're going to find out. So here's some of our questions. And today we're going to be thinking like a scientist once again. And the first thing that scientists do is come up with a question and come up with something that they're trying to figure out. So in this picture right here of the hot air balloon with the flame, we had, just a quick reminder, we had if a gravitational force pulls objects down, as demonstrated by our last experiment, what makes the uncrushed paper fall slowly? But more importantly, how can we prove something that we cannot see? So we're going to have to look for some evidence without actually seeing direct evidence of invisible particles or particles that are too small to see. So just a quick reminder, we observed that the flat paper fell more slowly. We observe in this picture right here that the balloons are not falling. Just a quick reminder, a quick vocabulary break review from last week is that mass is an amount of matter or substance that makes up an object. Okay, so the tennis ball in this picture has more mass than the paper, but they fell to the ground at similar speed when they were in similar shapes. Step two is we're going to come up with a hypothesis. So in step two, thinking like a scientist, which is an educated prediction, since we can only observe air as keeping up the parachute, or the balloon, we might hypothesize that the air is slowing down the paper and holding up the balloon because air has mass. Okay, so air has mass. Then we have just a quick science and history. The first hot air balloon was in 1783. They actually used helium, hydrogen. Hydrogen is the number one element on the periodic table and is extremely flammable, which when you're heating it up is not necessarily a good idea. There was quite a few accidents, so now we just use air. We had to come up with a new vocabulary word, a new vocabulary break. So in this picture we have a candle with somebody's warming their hands in front of it, and our vocabulary word we're going to be using today is radiation. And radiation is the transfer of heat through empty space. So you're not touching it, but you're still getting warm because you're near it. So radiation, once again, is a transfer of heat through empty space. All right, so step three, think like a scientist. We're going to experiment. We're going to try to build a hot air balloon to show that air has mass, and as it's heated through radiation, it will become more dense and then rise into the air. Okay, so we have a couple conditions real quick. I have a 6 micron, which is very thin, 4-gallon bag. This is going to be the envelope of the balloon. I did ask the studio to lower the temperature in the room to around 68 degrees, so if you do this at home and it's really hot, it won't work as well. If you don't have these thin bags, you can sometimes use a supermarket like a fruit or vegetable bag. We have a 4-slice toaster to generate heat, and that's about it for right now. It's all we need to start the experiment. Okay, so I'm going to put down the toaster, or turn on the toaster oven. We're going to wait a few seconds for it to go on, to get warmed up. But why we do that, just to make sure that there's nothing in it. You can obviously see that it's folded flat, like it's folded in a ball. If I drop it, it falls to the ground slowly. Even if I put it in a ball, it goes down slowly. So it's just a regular bag, no tricks. Okay, so that I can feel the heat coming up. I can feel the radiation coming from the toaster. I'm not touching it because that would be conduction. Conduction. Okay, so as I go, you can see that my bag went from being formless, and you can see that it's capturing the hot air. And this is kind of what we're trying to show, is that the hot air expanded the bag because it has mass, and it pushed the bag out. And so when I let go of this bag, it should rise in the air, and we'll see how far it goes and what happens because of that. So I'm going to let it go in 3 seconds, just making sure it's all filled up. Okay, I'm going to let go, and it did go pretty far, but you'll notice that the next part of being like a scientist is to analyze. We have to ask what happened. So we come up with 4 different things that happened in that quick experiment. Is that we noticed, and I have them here in this slide, is that the toaster warmed the air above it through radiation. It can still feel the heat. The balloon expanded and changed shape as it captured the heated air. The balloon rose into the air, defying gravity at first, and at first gravity did not pull it down. Then we had a kind of a problem. The balloon tilted to the side so that the opening was not down and the hot air was able to escape going up, and the balloon collapsed and gravity went back down. So we'll do the experiment one more time just to double check our results. So my bag is flat. Do not try this at home without a parent, because if you get too close to the toaster, you can burn your hand. So we're going to do it again. See if we have the same results. So let it go. It didn't go as high this time, but you can see when it turns to the side, the hot air does escape, and then gravity pulls it back down again. Okay, so what is our final results is the balloon was able to expand with heated air. By expanding, we prove that air has mass. Heated air makes the balloon get bigger. Since the heated air made the balloon expand, we could actually see the invisible air. And I said C in parentheses. Okay, so our simple hypothesis stated that air could slow down the paper and hold up the balloon is mostly correct. We should come up with more aired and varied experiments to look at the same problem from another angle and prove our theory has mass. Prove our theory that air has mass. Okay, step 5, thinking like a scientist. This is one of the most important things. We need to report our findings so that other scientists can repeat the experiment and prove our findings and confirm our findings. So different results lead to more questions. Why did the balloon tilt so that the hot air escaped? Can we design a hot air balloon to always keep the envelope opening down? Will that keep the balloon rising? And then, so what I have here is I have some tape, just regular Scotch tape. I have some coffee stirrers that I was able to cut into smaller pieces. And so what I'm going to do real quick, I'm just do a very quick, to take some tape. I'm going to add some weight to the bottom of the envelope. Now this is going to be very quick, so we'll see how it works. If I add too much weight, the envelope, the mass will become too high, and the hot air will not be able to rise it. So I can't just add a lot of tape. So I'm just going to add 3 or 4 pieces of tape real quick to see if I can keep the envelope down. And then hopefully we'll reach the ceiling. Now, I didn't measure the sides, and I'm not putting them in any kind of strategic order, just mostly for time. But we could probably do a better job at this with a little bit of thinking of where we might place these pieces of weight. Okay, so I kind of added 4 pieces of weight. So I'm going to start my toaster again, let the radiation start rising, the heat start rising. So I have 4 pieces of tape, 4 small pieces of coffee stirrer, and we'll see if I was able to balance it out a little better. And so it did go to the top. You can see because of the weight on the side, it was able to keep its envelope a little more down, a little facing down a little longer. So we had a little bit more success in getting it to the top. So for questions for next time, so we proved that hot air rises, but why? Why is it so special about hot air that it causes the balloon to stop gravity from pulling the balloon down? These are questions for another day, but here's a hint. Heated particles like to move. Thank you.
Thank you so much, Brendan, for that exciting lesson. And kids, make sure your parents are around if you're going to use the toaster. On behalf of everyone here at FSD TV, my name is Mark Sonny, and we'll be back again tomorrow.